Hi everyone, it's Michael. So I have another very fun problem for you guys today. I'm not sure the original source, but it was posted on the Art of Problem Solving forum, and it has a simple initial configuration, but I didn't find it was that easy. But I'm not sure, maybe there's an easier solution that you guys can find. So if you want to try to solve it, feel free to pause the video. Alright, so I'm going to go over the solution. So we have a triangle ABC with circumcenter O, and the bisector of BAC meets BC at D. M is a point so that MCB is 90 degrees and also MAD is 90 degrees. And lines BM and AO meet at point P. We want to show that the circle centered at P and passing through A is tangent to the segment BC. So I'm going to start with a couple things I observed. So I'm going to draw the circumcircle of ABC. And whenever I have an angle bisector, in many problems it's useful to extend it to meet the circumcircle at a point E. So that's what I'm going to do here. And one thing I want to note is if it were true that the circle centered at P and passing through A were tangent to BC, then that means if we take a perpendicular, let's say K, to BC, then that would mean that PK would have to equal PA. That's equivalent to this condition, right? But we know that OA is equal to OE. So if PA is equal to PK, and PK is perpendicular to BC, and OA is equal to OE, and OE is also perpendicular to BC, then that would basically mean that A, K, and E would have to be collinear. So basically that would mean that K would be point D. So really we want to show that PD is perpendicular to BC. So that's kind of the whole goal of this problem. How do we show that PD is perpendicular to BC? And if PD were perpendicular to BC, that would mean it would be parallel to MC. So then we'd have the ratio BD over DC is BP over PM. So we want to show that those ratios are the same. But by the angle bisector theorem, BD over DC is AB over AC. So we want to show that AB over AC is BP over PM. So how do we do it? So I'm going to do something a little clever here, but I've seen the similar idea in many problems before. I'm going to take BA and I'm going to extend it to a point. I'm not sure what I'm going to end up calling it in the end, but let's say F, so that AF is equal to AC. And why am I doing that? Well, I wanted to show that BP over PM is AB over AC, but if I could show it was AB over AF, so where AF is the same as AC, then I would want to show that FM is parallel to AP, and that might be a little easier. So that's what I'm going to do here. I'm going to construct a point F, and I'm doing it in a way so that AF is equal to AC. So I'm going to write that out. So let F be on ray BA so that FA is equal to AC. And now I want to show that FM is parallel to AP. So how do I go about doing that? So here's going to be my trick. So the problem says that angle MAD is 90 degrees, and many of you probably know that that means that MA is the angle bisector of FAC. That's not hard to see because if AD is a bisector of BAC, half of angle BAC plus half of angle FAC has to equal 90 degrees. So since MAD is 90 degrees, then MAC has to be half of FAC. So basically, since AM is an angle bisector of FAC and AC is equal to AF, we have a symmetry in this problem. So I'm going to write out a couple more steps. So like I said, angle FAM is equal to angle MAC. And now the thing is, what we can see, and I probably might have shown this in a longer way than I had to, but basically, angle, we ultimately want to show that AE is parallel to FC. And that's not hard to see because FC has to be perpendicular to AM by symmetry, because AM is an angle bisector and AC is equal to AF. So since FC is perpendicular to AM, FC has to be parallel to AE, because AE is perpendicular to AM. So I'm going to write out a little longer proof of it than I just said, but it gets you to the same place. So basically, since AF is equal to AC, angle AFC has to be half of 180 minus FAC, and 180 minus FAC is angle A, and half of angle A is angle BAE. So if angle BAE is equal to angle AFC, then FC has to be parallel to AE, and I'm going to draw in segment OE. So what am I getting here? So I ultimately want to show AP is parallel to FM, and I'm going to do it in a kind of interesting way. So we know FC is parallel to AE, and it's also easy to see that MC is parallel to OE, because they're both perpendicular to BC. And also triangle FMC has to be similar to triangle AOC, and so that's going to help solve the problem and show that FM is parallel to AP. So I'm going to write that out. So we have so first of all, yeah, MC is perpendicular to BC and OE is perpendicular to BC. So that means MC has to be parallel to OE. And we showed that FC is parallel to AE. And by symmetry, FM has to equal MC because of this arrangement. Since AF is AC, it's clearly true since AM is an angle bisector. So since AM is perpendicular to AD, like I said before, AM has to be perpendicular to FC. So that just proves that MF is equal to MC. And also AO is equal to OE because all radii are equal. And so those two triangles have to be similar. Yeah, so like I said, triangle AOE is similar to triangle FMC. And if you have two similar triangles and two sets of sides are parallel, so MC and OE are parallel, and FC and AE are parallel, then the third set also has to be parallel. So FM is parallel to AP. And if FM is parallel to AP, that means now we can use ratios on the triangle BFM. And so we would get AB over AF is BP over PM. So I did a little more work here already, so I'm going to show you guys. But the problem is essentially solved from what I was saying before, because BD over DC is equal to AB over AC. That's by the angle bisector theorem. And AB over AC is AB over AF. That's why we constructed point F, actually, so that we could do this. And AB over AF, well, now that we know that FM is parallel to AP, AB over AF is PB over PM. So by the transitivity, we have BD over DC is equal to BP over PM. And so that means that PD has to be parallel to MC. And if PD is parallel to MC, well, MC is parallel to OE. That's pretty clear, and we mentioned it before. So PD has to be parallel to OE. And now we're basically there, because that means that triangle APD is similar to triangle AOE. And so AP over AD has to equal AO over OE, but those are both radii, so that's equal to 1. And so AP is equal to PD. And so basically, if AP is equal to PD, that means if you take the circle centered at P passing through A, It also passes through point D, and it's also PD is also perpendicular to BC. So that solves the problem, because that means that that circle is tangent to the segment BC. So I hope you all like this problem. A little easier than the last one, but still not that trivial. So if you liked it, please give it a thumbs up. And if you want to see more, feel free to subscribe to my channel. Thanks, everyone.